In today's video, we're going to discuss the measures of center. The three most common measures of center are mean, median, and mode. Now, mode, as you know, is the number that occurs most often. Distribution might be unimodal, and then it has one mode, bimodal, that it has two modes, or multimodal, it might have multiple modes. Let's review how to calculate mean and median. Mean, symbolized by x with a bar over it, x bar, which we often think of as average. To compute the mean, we find the sum of all the values of x, and then we divide by the number of data points we have. So mean, you can visually think about it as mean is the balancing point. It's, as you can see in this graph, it's the point where it balances all the data. And let's look at how to compute the mean. Let's look at this easy example. To find the mean, we add up all our data values. So I'm going to take my summation of all my x's, and I'm going to divide by n. So x bar, make sure you use this notation when you show your work, is 1 plus 2 plus 3 plus 4 plus 5 plus 6. And then I'm going to divide it by how many data entries I have, in this case 6. Simplify my answer down, I get 3.5. So x bar, or mean, is equal to 3.5 in this example. The median is the number that divides the data set in halves. So you organize the number in increasing order, and the data entry in the middle is your median. If you have two data entries in the middle, you add the two middle numbers and divide by 2. So we're dividing the distribution into two equal areas. Okay, let's practice this in an example. Okay, we're going to find the median from the following data set. Let's say I had the numbers 1, 2, 3, 4, 5, and 6. It's already in increasing order. If it's not, that's what you need to do first. And then you find the number in the middle. Well, I have two numbers in the middle, 3 and 4. So I add them together and divide by 2. That makes my median 3.5. Let's say I had an odd number of data points. Let's say we had only the numbers 1, 2, 3, 4, and 5. It's already in increasing order, and I just find the number in the middle, which is 3. So my median is 3 in this example. Okay, suppose we have 5 third graders, all about 4 feet tall, are standing around with their teacher, who is 6 foot tall, joins the group. What is the new mean height? So recall that mean is calculated by finding the sum of your x's divided by the number of entries. So mean, we have 5 third graders who are 4 feet tall, so I got to add 4 5 times. And then I have my 6 foot tall teacher, so I'm going to add 6 one time and divide by the number of people standing around, which is 6. To save space, I could have also calculated the mean. Since I'm repeating this for 5 times, I could write that mean is equal to 5 4s, or 5 times 4, plus the 6, divided by our total data points of 6. I don't care which way you write it. So let's actually do the math. Let's calculate, adding up all our 4s. So 5 times 4 is 20, plus 6, we got 26, divided by 6. Therefore, our mean is approximately 4.3. So our mean went from 4 up to 4.3. Next, it asks us to find the new median height. So median, remember I need to replace write the numbers in increasing order. So I have 5 4s, 5 people are 4 feet tall. Then I have my teacher, who is 6 foot tall. The number in the middle, so I have an even number of values, so 4 and 4. So when I add the 4 together by 2, I still get 4. So the median height was not impacted by the outlier of the teacher. The median is still just 4. Since this is a word problem, what you need to get in the habit of, anytime that you have a word problem, let's translate what our answers are into a sentence form. You can write something like, the new mean height of the group is approximately 4.3 feet, but the new median height remained the same at 4 feet.
We're going to look at how to find the mean, median, and mode when you're given the graph and not the raw data. So let's start with mean. Mean, you recall, is the summation of your x's divided by n. So on a dot plot, that means I'm going to take 16.1 plus 16.3 plus 2 times, because I have 2 dots at 16.4, plus 3 times the 16.5, plus 10 times 16.6, plus the 6 times the 16.7, so I have 6 dots at 16.7, 2 times 16.8, plus 1 times the 16.9. And I'm going to divide that by the 26 data entries I have. Using my calculator to help me out, I discovered that the mean is approximately 16.592. To find the median, we'll find the middle number. Well, I know that n is equal to 26. So if I take n plus 1 divided by 2, 27 divided by 2, and I get 13.5. That means at the in between the 13 and 14 spot is my median. In this case, that will be 16.6. Mode is the one that occurs most often, which is obviously 16.6 weights, 16.6 ounces. Notice that this graph is approximately symmetrical, and also notice that my mean is approximately equal to my median. On a histogram, when you have a range of values, the minimum and the maximum value for each bar, you find the number in the middle. And then we assume that every data point is that value. So for the first bar, I have 3 times 62.5. For the second bar, I'm also going to have 3 times 67.5. And I continue that pattern for each bar in the histogram, adding the totals together and then dividing by the number of data points I have, or dividing by n. So mean is equal to, if I add all these up, it's 2,332.5 divided by 31. So I get a mean of approximately 75.242 feet. Median, I know I have 31 data entries, so 32 divided by 2 is 16. So I need to figure out 16. That represents 2. My first bar has 3 data entries. 3, and then 8, and then 10. So adding 3 plus 3 plus 8, I don't quite reach 16. So I know I'm going to be in this bar. Median, is approximately 77.5. Now notice they're not exactly the same because I had to approximate a little bit, but they're very close. They're pretty close. The mode is the value that occurs most often, so my mode in this value would be 77.5. Here we have a skewed data set. I'm just going to label the heights in these bars that I'm going to use. When you have a graph like this and it might be hard to determine the exact height of each bar, I highly suggest that you label it so I know which information you used. So to find my mean, I take 138 times the height times the midpoint of that bar in the histogram, so it's about 2.5, plus 60 times the 7.5, and I continue adding this up, timesing each of these, assuming they're at the mid value of each bar in the histogram, and then divide by the total number of data points. The summation of my x is simplified down to 2,805 divided by 290. So my mean is approximately 9.672. Now we're going to calculate the median. So it's going to be my middle value. So I know n is equal to 290. So 290 plus 1 divided by 2. is 145.5. So the mean is going to be in between the 145 and 146 entry value when I go from smallest to largest. And that is right there in this bar. My median is approximately 7.5. My mean is 9.672. Mode is obviously the 2.5. Is that very first bar. So 2.5 still in basis. See, my mean is much higher than my median in the SKEW data set. And one of the reasons for that is resistant measures and non-resistant measures. A resistant measure is a measure that can resist the influence of extreme values. So let's look at the SKEW data set. Our median is a resistant measure because it did not be influenced by the outliers, but our mean was influenced. So because the mean cannot resist the influence of extreme observation, we say that it is not a resistant measure of center. However, the median is a resistant measure of center. The fact that a median is a resistant measure of center is the reason when we have SKEW data set, we always use the median to represent the measure of center because it's not influenced by these outlier values that the mean is heading toward.